Force to. Oh, okay.
Welcome back to Built to Ship, the podcast where we go behind the scenes with founders and product leaders, shipping real AI products into the world. I'm your host, Tyler Postal from Voker, and today I'm excited to be joined by Jeffrey, co-founder and CTO of Flair Labs, a multi-channel AI platform for real estate and lending that uses autonomous agents across voice, text, and email to handle customer communication. Jeffrey, it's great to have you here.
Hey, thank you, Tyler, for having me, and very, very nice to meet you guys. So today I'm going to, do a little bit of casual talk about what our company is doing right now, and hopefully that's going to help. Yeah.
Yeah, sounds great. Well, why don't we start a bit with the founding story? What were you doing before Flair Labs? How'd you meet the team? How'd you get the idea?
Yeah, I think that's well, I would say that's a pretty traditional story. So I actually, spent the 3 year in the college, and once after that, I took that, the fourth year, which I supposed to be a senior, and I took that extra year and then come to the Bay because I know that's where all the founders met. And I started to, working on some small projects, initially, and that at the very beginning, I was trying to do something like tax agent on the e-commerce side, which basically I build a small agent under the Shopify, and that's basically help you explain, when you click into the website, that small agent will pop up like a text bar, like where the old age, when the ChatGPT just got emerged. But like I sort of hear, oh, that actually didn't work out pretty well. So I'm starting to join, a lot of hackathons, and it happens I met my co-founders, two co-founders, Samiri and Eddie, in one Stanford hackathon. They both are from
Wow.
Stanford, and we just happens to work together with the projects. So what we're doing back to then is actually very simple. Is we use like AI to do like a call transcript analytics. So basically, analyze the emotions, semantic, like what can we do from there, right, for the call centers. And then we actually think that's a pretty cool idea, and because we got like a one company called Realty.com, and who's one of our very, very initial clients, when we were actually doing the call analytics for them at the beginning.
Oh, wow.
But then, at the things progress, we figure out that like they're basically doing this, calls very repetitively, like with the same pattern. And and that was like 1 year and a half ago. And the voice AI is not that popular yet. I know there's some player started much earlier, but it's not that popular because the techniques are not mature enough to handle all these interruption, endpointing, and so on. And say, hey, why won't we just build our own voice AI? So that we can be the call center for the real estate team and those lenders team. So then we happen to build this thing called Flair AI. Yeah.
Amazing. Love that story. And it's really awesome how much building's going on in the Bay and all sorts of places with these hackathons. A lot of people who didn't used to think they were builders are now able to go out there and build tools using AI. Tell me a bit about, your customer and your product at a really high level. I know you mentioned that, real estate vertical, but what do those look like? Is it really large enterprises? Is it
Yeah.
people owning apartments? Yeah, talk about
We
that.
heavily focus on the large enterprise. So we obviously focus on the real estate and mortgage spaces because one funny reason is because the initial five customer, like they all happens to be from the real estate section.
Mm,
And then we start to think about, oh, is the things we're doing really attractive for those like real estate players? I mean, it ends up not being like 100% true, but we were thinking in that way at the beginning because that's what we see, right? And we start to working towards that field. And later on, we noticed that there's a lot of difference between the verticals. In the healthcare, it's a total different game playing methods than you play in the real estate field. Anyways, our clients, like 60% of our clients are all big enterprise. So one of our big enterprise clients include Vast Capital Lending, which they takes like make some millions of loans like every year, and so they have
wow.
a lot of applicants, and we do around 2 million calls million for them per month.
Wow.
So that's a very, very large client, and we also cooperate with some of other CRM team. So the real estate CRM, and we basically play as a solution for them, and they will introduce our product to their clients, and their clients will help to communicate with the home buyers and all these kind of these agents. Yeah.
Amazing. So, one of those top clients, millions of loans a year, millions of calls a year or a month. What are the kind of things that people are calling in and asking about? Is it really varied? Is it one specific thing?
Well, that's actually a good question because I think the people coming here is just like coming for a reason, right? Because we don't call the cold leads. Everything we call, every people we call, they already sign up something. They are looking for like home buying or selling homes or looking for mortgage already. So what we did is just we do like a warm reception before the agents get in touch to make sure they are qualified enough and also make sure they have the enough intent to move forward within a short period so that when the agents see this deal they can we can hand off to them and they can get this lead funded as soon as possible. Then that being said, this makes the whole process smoother, and a loan officer gets happy because they'll get like a commission fee for every deal they make. So basically that's a win-win game for all of us.
So it sounds like you guys are helping with the qualification of these leads and helping to intake, the inbound demand. What are you're at some real scale there with millions of calls a month. What are some of the main challenges you've seen with building voice agents at that
Well,
scale?
yeah, I think that's a lot of story we can talk. Obviously at the beginning, when the voice is not that developed, the first thing is how do you make sure the memory doesn't get bloated? Because as the conversation gets longer, there's like actually there's a plenty of leads that talk with our AI more than 30 minutes. And that's actually a
Wow.
very long time. And we don't just see in the edge case, we have like around like 3 to 5% actually talking
Wow.
with AI longer than 30 minutes. I think that's a quite impressive number comparing to like,
Definitely.
yeah.
That's a
And
lot of turns.
yeah, because they sometimes they don't realize that's AI. So the first thing comes to how do you manage these all like long contacts to make sure like the AI don't hallucinate and be dumb, ask the same question they already had before. That's pretty challenging task at the beginning. So what we did is we have like a sub agent running at the back end. We collect around the slot collections every turn so that we make sure we update the memory with a very minimal latency. And speaking about latency, maintaining your voice agent like under 700 milliseconds in production is pretty hard because you see all these demos kind of things like they play on the web and they like have very low latency. I mean, that's good to hear because that's not what you heard from production because
Yeah.
there's a lot of things going on. Like depends on the telephony you selected. If you go with Twilio, Telnix, any other phone number provider, or like are you using LabKey to host your own like video conference or audio conference, right? Depends on how you play the music track, and that can all adds up a thing small a little bit, and that makes latency is very hard problem to solve, right? And one another big thing, obviously, at our current call scale, we have like a trouble to get the 5 minutes SLA because we
Mhm.
are making so many concurrent calls at the same time, and our clients expect like whenever there's a new lead, we need to get to the lead within the 5 minutes they get into the queue. So that require a very solid backend together with the cloud, Redis, distributed system, of course, because we have multiple instances handling how do you synchronize between the instances, and these are all a bunch of details I can get into.
Amazing. So, I mean, one of the things I'm picking out from what you're saying is that, building a at scale agent system is not just modifying prompts. It's a lot more behind the scenes. It's a full stack engineering problem. There's
Yeah,
infrastructure, there's, still cloud providers like Redis and, things like that. Sorry, did you have something to add there?
yeah. I think building scalable agents. So I think began with voice AI because we all think this is very interesting. Think about like you get a call from AI, but you couldn't tell. I just feel like that's very cool. I believe that become the future of the communication because there's many communication we can simplify right now, but the reality is a little bit different than what I think as I build forward, right? Because you cannot always be like trying to play with your agent, and you need to deal with like a real request. And at the meantime, you can play with it. But one core thing is that, like you need to build a very scalable system that can easily deploy the agents throughout the companies with a minimal change, and
Mhm.
also you need to scale the same conversation to a millions scale So that's going to be a very hard part. So like building the prompts, like doing like the memory cleaning and turn taking is just within a single conversation. But how do you make that conversation stable across millions? That's going to be very challenging.
Definitely. No, that's the kind of thing that you only learn once you get to the scale, right? If you're building a pilot or an MVP, you probably think it's a lot simpler. So it's great to hear directly from you guys, what these challenges are. I want to ask about like sort of agent architecture, or let's just say like model architecture. I hear a lot in the voice space that speech to speech is great for latency, but it's also like less intelligent and has poor reasoning capabilities. Do you guys use text to speech to speech to text, or what's your
So
sort of flow?
we build upon like we have a speech to speech model as well, but I think we don't use that quite frequently, and we only use that in the use case where you have a very short conversation, like we briefly go to with like 3 to 5 turns, because the speech to speech model have a great conversation experience, but it's gonna be dumb sometimes when calling the functions because it doesn't train pretty well on the function tool calls from my experience. So we do the testing on the well-known speech model, speech to speech model, like obviously Google native and a few others, and we noticed that the accuracy from that tool call is not as good as the LLM model, of course. So as for those like longer conversation, we still trying to use the traditional way where we build a transcription and the LM inference and do a text to speech. But the key part to reduce the latency that is actually the endpointing, right? Because the endpointing determines how and when do you start to generate a speech response. And that point can be very tricky because if you can somehow generate that a little bit earlier, then the latency actually reduce a lot because 90% of times the bottleneck going to be the LM generation. That's going to take much longer. Majority of the time during the flow. And so what we did is actually we do a 2-turn prediction, right? So we have we self-hosted endpointing model, which we predict the user's turn as a like eager speech and also the true speech ending, right? So if there's a eager speech at the user say something and pause a little bit and our outputs are like eager of end of turn, that means that probably signal early sign of the user about to end. So that's where we actually begin to prepare the generation beforehand. And after that, if we buffer that a little bit and there's another like user speech coming in, that means we actually have a false positive, right? And then we need to discuss this buffer and regenerate. But most of the time, 80% of the case, that small buffer going to give you around like 200 millisecond reduction in the latency, which is very good.
Wow.
And also it depends on the obviously the text to speech provider and what kind of providers you guys might have. You can self-train the whole self-hosted Sesame, like use them in house, and you can also use the great product like Minimax, Cardiccia. These are all have a different factor on latency. And from my experience, the Cardiccia and Minimax plays pretty good in terms of that.
Very interesting. So to make sure I'm understanding, because I think this is a huge insight that you're sharing here, you guys do some amount of like prediction. Hey, the user's probably about to be done with their thought or done talking. Let's prepare, a response. And if you're right, you'll have like a few extra seconds of buffering to send that response and to, have already done the inference,
Right.
and it'll reduce latency. If it turns out they weren't done, do you just cut off the inference and then like kind of reset the step and wait till they're done to do inference?
So if the user come after didn't finish, we predict wrong and still talking, I mean that's the same as what you will get like with the there's nothing bad on that. But 80 and even 90% of the chance you will get like a faster latency in terms of that.
Very interesting. Yeah, thanks for sharing that insight. I think that could be something that could unlock, latency for a lot of people. Before we start to close out, I do want to ask about tools. You mentioned them a couple of times that like speech-to-speech models aren't great at tool calls. You also mentioned sub-agents before. When it comes to sub-agents, how are you having your main agent sort of hand off or delegate tasks to the sub-agent? Is it through tools? And approximately how many tools do you give the system? Any tips you have for, what's a good number or too many tools or how to handle tools at this kind of scale?
Well, I think sub-agent is just a decision choice because that just happens to fit our architecture pretty well, and we did that through the tool. But I think the clear the very clear design thought at the very beginning is how do you gonna design your conversation, right? Because we think the conversation is a graph, and we think like a state machine. So every turn taking and also a state transition is gonna to trigger different actions, and that's actually how we handle like many um, function tool call. For example, if the agent gets to a transfer stage, you're going to trigger that the transfer tool call, and by the time you transition to the next stage, there any like edge action you want to perform, right? Update your memory, send a notification, whatever. So like design your conversation well, like in a good data structure that fits you actually benefits a lot because given that we can have a lot of capabilities on putting different tools inside that.
That's great. Well, last question before we start to wrap up. Voker's an agent analytics platform, so we love to ask people this. For people like you guys who have real scale, real agents in production, it's obviously very different from when you're like in a pilot or an MVP. How do you keep track of how your agents are doing? Because people might use them for things you don't expect. They might fall into multiple failure modes. How do you like to monitor and keep track of agents at scale?
Yeah, that's a very good question. So because at beginning, so there has to be like a prompting efforts, right? Because we all know that there's a certain way we need to refine, put the guardrails on an agent. So very important aspect is you need to figure out all the possible edge cases in your conversation. Because if some of them release say, hey, I have a car accident, we cannot just say, okay, let me get you booked with appointment, right? We cannot say that. So we need to acknowledge what they said, and then just go from there and see if they're still willing to talk or if they want to schedule another time. And this is very important. So this depends on how you build the metrics, right? So the way we did it is we sample some of the conversation, right, every day. So we have a background analysis doing like for each week, and we'll able to see what's the most common failure pattern there. And we have already identified like a bunch of them. And so we also have like a small assistant team help manually review some of the calls. That's going to be very necessary because even that's pretty dirty work you might be reluctant to do, but it's quite important and critical for your conversation quality. Yeah.
Amazing. Well, thanks again, Jeffrey, for sharing all these insights. I want to put your website up on the screen. It's flairlabs.ai. Please share with the audience, who should check out Flair Labs. How do they follow along? How do they try out the product?
Yeah, I think just very, very, very good because this website we actually didn't do quite a lot of updates on that because mainly my customer was mainly on an enterprise. Because if you guys are very interested in getting familiar with our product or even getting to use it, I feel free to just search my name on LinkedIn and also search a Flair and to get my LinkedIn so we can get in touch and we can start from there.
Amazing. Sounds great. Well, again, thanks for joining me on Built to Ship, Jeffrey. It's been great to hear about, how you've built these multi-million, monthly active agent products. For those listening, thanks for tuning in, and we'll see you next time on Built to Ship. Bye now.
Okay, thank you, Tyler.